Is time travel real, or is it just a science fiction fantasy? To answer this question, we first have to understand what time actually is. Is it a river that flows at a constant rate? Or is it more like a dimension that we can move through, just like space? Most of us experience time as a linear progression from the past, to the present, and into the future. We mark time's passage by the ticking of clocks and the turning of the earth. But what if I told you that time is not as straightforward as we perceive it to be? Einstein's theory of relativity completely changed our understanding of time. It showed that time is not absolute, but is relative to the observer. This means that time can pass at different rates for observers who are moving at different speeds, or who are in different gravitational fields. So, can we manipulate this relative nature of time to travel through it? Some physicists believe that time travel might be possible through wormholes, which are theoretical tunnels that connect two different points in space-time. Imagine a piece of paper, folded in half. A wormhole would be like a shortcut tunnel through the paper, connecting two distant points. If we could create or find a wormhole, it might be possible to travel vast distances across the universe, or even to travel through time. Another possibility is to travel at speeds close to the speed of light. As we approach the speed of light, time slows down relative to a stationary observer. If we could travel fast enough, we might be able to travel into the future. One of the most intriguing theoretical scenarios for time travel involves black holes. These celestial objects possess immense gravity, so strong that not even light can escape their pull. According to Einstein's theory of general relativity, time slows down significantly in the presence of strong gravity. This means that if a spacecraft were to orbit a black hole for a while and then return to Earth, more time would have passed on Earth than for the astronauts aboard the spacecraft. They would have effectively traveled into the future. However, even if we could overcome the technological challenges of traveling near a black hole, there are still many unknowns and potential dangers. The intense gravity could rip apart a spacecraft, and we don't fully understand the effects of such extreme environments on human physiology. While the idea of time travel is captivating, it comes with a whole host of paradoxes and philosophical dilemmas. Perhaps the most famous is the grandfather paradox. Imagine a scenario where you travel back in time and accidentally kill your own grandfather before he met your grandmother. If your grandfather died before he had children, then how could you have been born to travel back in time in the first place? This paradox highlights the potential contradictions and inconsistencies that arise when we tamper with the past. Despite these challenges, the pursuit of understanding time travel continues to fascinate scientists and the public alike. While we may not have flying DeLoreans or time-turning devices just yet, the exploration of time travel pushes the boundaries of our scientific knowledge and forces us to confront the fundamental nature of reality itself.